Hello, 7th graders, and welcome to our first lesson on Chapter 8. In Chapter 8, we're going to start some geometry. We're only going to do Lesson 8.1 from the textbook, which is on similar shapes and scale drawings. So we're going to look at graphing on a coordinate grid, and we're going to look at ratios in scale drawings. All right, because ratios have a lot to do with scale drawings, let's remember what we did way back in Chapter 4 when we learned about proportions. And let's practice them a little bit at the bottom. So when we learned about proportions, we learned about unit rates. So we would start by finding the unit rate on this side and do 18 divided by 30. And that would be our unit rate per one unit, if 1 is the denominator. And then we would multiply by 5. So let's first solve this way. 18 divided by 30 is 0.6, and then we take 0.6 multiplied by 5, and we get 3. So x, in this case, would be 3. Now, I want to show you guys another way to do this. It's called cross multiplication. In cross multiplication, you take the cross products, so the denominator of one ratio and the numerator of the other ratio, multiply those, and then you take the numerator of the first ratio and the denominator of the second ratio, multiply those. So in the example they have shown, I have a over 4 equals 27 over 18. So I would take a times 18, cross products, times 27 times 4. Those are my other cross products. And so a times 18 should be equal to 4 times 27. And now we simplify. So 4 times 27 is 108. A times 18 is 18a. And I know I solve for a by getting a by itself. I have to use the inverse of multiplication. So I divide both sides by 18, and I get a equals 6. So that means that 6 over 4 equals 27 over 18. All right, so let's solve number 9 this way. We're going to take the cross products. So 5 times 18 is equal to the other cross products, 30x. I type 5 times 18 in my handy-dandy calculator, and I get 90. Then we divide both sides by 30, and we get x equals 3. Same answer we got when we used unit rates. All right, I want you guys to try number 10 and 11 on your own. Pause the video, play it back to see if you got it right. All right, in number 10, we get 12 times 24 equals 36x. 12 times 24 is 288. Then we divide by 36, and we get x equals 8. All right, and in number 11, take our cross products. 3 times 3 equals 9x. 3 times 3 is 9. Well, if 9 equals 9x, divide both sides by 9, x equals 1. So one way ratios and scale drawings and scale models are used is in map making, construction, and even some other trades. We're going to see how it looks in map making and architect. So a blueprint is a technical drawing that usually displays architectural plans. Architects build blueprints for their job. Pete's blueprint shows a layout of a house. Every 4 inches in the blueprint represents 3 feet of the actual house. That seems like a pretty important ratio. We're going to write that down. 4 inches equals 3 feet of the actual house. One of the walls in the blueprint is 24 inches long. What is the actual length of the wall? Now, we could solve this by making a table and counting it out. I know 4 inches equals 3 feet. So if I multiply them both by 2, that ratio is equal to 8 over 6, which is equal to 12 over 9. Do you notice a pattern in both the top and the bottom? The top numbers are increasing by 4, and the bottom numbers are increasing by 3. So I could continue to count out 9 plus 3 is 12, plus 3 is 15, plus 3 is 18, which means that when the blueprint is 24 inches long, the actual length of the wall is 18 feet long. And I have my answer. I could also set up a ratio. So I could have set up a ratio if 4 inches equals 3 feet, then 24 inches equals how many feet? Then we could solve this with cross products like we learned in the review of chapter 4. And I would do 3 times 24 equals 4 times, we'll just say x for the question mark, so 4x. And 3 times 24 is 72. And then we divide both sides by 4. And we get 18 equals x. So same answer, both ways. You could make a table and actually count it out, or you could do cross products, whichever one seems easier for you. Let's try this one more time. In Pete's blueprint, the length of the wall is 16 inches. Find the actual length of the wall. Well, we already counted out in our table where it's 16 inches, it's 12 feet. We could also solve this by putting up our ratio. 4 over 3 equals 16 over 12. Another way to solve a ratio, if the numbers are products of the numbers in the other ratio, is by thinking, how does the ratio change? So to get from 4 to 16, we multiply by 4. To get from 3 to 12, we can also multiply by 4. All right, last one. A little hard to read with the writing over it. The back of the wall of the house is 33 feet long. What is the length of the back wall in the blueprint? Now we have a different ratio to solve for. We know it's still 4 over 3, 4 inches over 3 feet. But something really important when you're setting up your ratios is to make sure that the units match up. So in my second ratio, I also need to have inches over feet. If I switched it up and had feet over inches, my units wouldn't be consistent and my answer wouldn't be right. So if I have inches over feet in this ratio, I have to have inches over feet in the second ratio. Okay, so the question is asking when it's 33 feet long, how many inches is it? So 33 is going to go here. And then we're going to solve by cross products. So 4 times 33 equals 3x. And 4 times 33 equals 132. Then we divide both sides by 3. And we get x equals 44. So the length in the blueprint is 44 inches. Notice how those ratios stay consistent. 3 to 33 you multiply by 11. You can also multiply by 11 to get from 4 to 44. So we've now learned 3 ways to solve ratios. We can build a table, we can cross multiply, and we can also think, how does one ratio get to the next ratio? In the example I just boxed, we multiplied both by 4. That's also called equivalent fractions. All right, next example. The art class is planning to paint a mural on an outside wall. This figure is a scale drawing of the wall. What is the area of the actual wall? Okay, well, we can see that the picture is 28 by 11 inches. We can also see that 2 inches equals 3 feet. So we're going to use that ratio, 2 inches over 3 feet. We can use that to find the unit rate. So we'll set up a ratio equals 1 over a number. To get from 2 to 1, we divide by 2. So we got to do that to 3. 3 divided by 2 is 1.5. So 1 inch equals 1.5 feet. All right, so then we need to find the actual height of the wall. And we're going to do this by multiplying 1.5 feet by 11. Since the picture is 11 inches, and I know each inch is 1.5 feet, so 11 times 1.5, that wall is 16.5 feet. Now, it might be easier for me to just go here and label 16.5 feet. We need to do the same thing for the other wall. So I'm going to take 1.5 times 28, since it's 28 inches and each inch is 1.5 feet. And we get 42 feet. So this one is 42 feet. And then we have to find the area. So we know area is length times width. So now we take 42 times 16.5, and we get 693 feet squared. Now, this question at the bottom makes a really good point. How could you solve the example without having to determine the number of feet represented by 1 inch? Well, on the last page, we were talking about ratios. If 2 inches is 3 feet, I could find the number of feet by saying, well, that's got to be equal to 11 inches over the number of feet, and cross multiply. So 3 times 11 is 33, which has to be equal to 2x. So then x is 16.5. Look, same answer. And I could also find the other wall length by setting up 2 over 3 equals 28 over x. 3 times 28 is 84. It's 3 times 28, which has to be equal to 2x. So x equals 42 feet. And look, same answer. I would still then have to find the area by multiplying 42 times 16.5, but there's another way to find the wall length. All right, so I want you to see if you can solve number 5 on your own. I'm going to walk you through how to solve it, and then I'll tell you when to pause the video, finish solving, and then play it back to see if you got it right. All right, so number 5 says, find the length and width of the actual room shown in the scale drawing. Then find the area of the actual room. So notice the length is 6.5 inches, the width is 5 inches, and 3 inches are equal to 8 feet. So you can solve this a couple ways. You could lay out a table to find the number of inches equal to the feet by starting with 3 inches equals 8 feet. But 3 doesn't go into 5 and 6.5 evenly, so I don't think that's our best option. You could find the unit rate by finding out what 3 over 8 is equal to, and then multiplying by 5 and 6.5. Or you could set up proportions. So if 3 inches equals 8 feet, that should also be equal to 5 inches over the right number of feet. And it should also be equal to 6.5 inches and the right number of feet. All right, so pause the video now. Solve for the area. So once you get those two values, multiply them by each other to find the area, and then play it back to see if you got it right. All right, I'm going to go ahead and solve it. I'm going to solve it by cross multiplication because that's my favorite. So 8 times 5 is 40. So I have 40 equals 3x. So then x equals 13 1/3, which we're just going to say 13.3. Was those. And then for the length, I have 8 times 6.5, which is 52. So 52 equals 3x. Divide both sides by 3. And x equals 17 1/3, or we'll just say 17.3. So then to find the area, you take 13.3 times 17.3. And your final answer should be about 230.5 feet squared. All right, for the last part of the notes today, we are going to look at drawing in different scales. So a scale drawing of a meeting hall is drawn on centimeter grid paper as shown. The scale is 1 centimeter equals 3 meters. I'm highlighting that because our scale is important information. Suppose you draw the rectangle on the centimeter grid paper using a scale of 1 centimeter equals 6 meters. In the new scale, 1 centimeter represents more or less than 1 centimeter in the old scale. Well, the old scale, it represented 3 meters. The new scale, it represented 6 meters. So now it's representing more area. The next part says the measurement of each side of the new drawing will be twice or half as long as the measurement of the original drawing. Well, let's draw it to figure it out. So if each side here is representing 3 meters, this is 3, each side is 3 meters. So let's see. There's 1, 2, 3, 4, 5, 6, 7, 8. This is 8 centimeters. So it's representing 24 meters. I got 24 by doing 8 times 3 because each centimeter is representing 3 meters. I could set up a ratio to solve that. 1 over 3 equals 8 over x. 1 to get to 8, we multiplied by 8, so 3 multiplied by 8, we get 24. So that's 24 meters. Now, if I'm going to draw another picture representing 24 meters, where each centimeter represents 6 meters, I could set up a ratio like this, and now 6 to get to 24, we multiply by 4, so multiply 1 times 4, and I'm only going to need 4 units. So my new box would only be this wide, which means it's going to be half as long as the original drawing, because 1 centimeter is representing more area, so you need less centimeters to represent the whole thing. All right, and that's it for notes today. Make sure you tune in to the Google Meet to see what you need to do for homework.